Lovely. So guys, welcome to day 3 of Thinking Beyond the Tides. Yes, today's day 3, today's Wednesday. And today's session is on marine technology and conservation in the Caribbean. And today we have Jeffrey Bernus, who is the founder of the Caribbean Cetacean Society. We have Dr. Brandon Bethel. I know it says Brandon, but it's Brandon, who is a physical oceanographer coming out from Bahamas. We have Michelle Cazabon Mannette, a sea turtle biologist and conservationist, and Dr. Kimberly Baldwin, a marine spatial information expert. Yesterday, we learned about marine spatial planning. So today we're going to see how to really use the technology for that. And I am very much excited. So to kick things off, we're going to start with Jeffrey. So the floor is yours. Take it away.
All right, let me just share my screen if it works. And then you all should be seeing it now, right? Is it working?
Just a little delayed. Yeah, all good.
All right, cool. I'll get slow. So good day, everyone. My name is Bernus Jeffrey, and I'm the director and the co-founder of the Caribbean Cetacean Society. I'm going to talk to you more about this. I'm a marine biologist from Martinique, and I'm pretty okay to spend a little time on question after this presentation. So today we're going to speak a little bit about the context in the Caribbean, about whales, dolphins, cetaceans, what it is, and why we do protect them. And I'm going to show you a little bit about the CCS, so this new NGO, and present you some research and cooperation project that we've done. So what is the results, and exciting, like how we use actually the technology to get those results, and then how you can get involved in 2023, 2025. So cetaceans, they're all the whales and the dolphins. So we don't talk about Mannette, we don't talk about only like all the marine mammals, but we talk only about whales and dolphins. You have a picture below which show you some species that you can find in the Caribbean. And in the video, if it's working on the presentation right now, you can see some images that we took in the Caribbean. So you can see Orca now, for example, which is like pretty new for some people that don't know their air. But why do we talk about them? You heard a lot about climate change, for example, and you need to know that marine mammal, and especially whales, do play a really important role in that, because they can capture 4 times more carbon dioxide than the Amazon forest, for example. So if you want to make a change, like a big change, if you want a nature solution and you would do something about climate change, saving the world is one of the solutions you can have. So the EMF, the International Monetary Fund, calculate that their value is $1 trillion per year. For all the whales, which is a lot. And they capture carbon dioxide, help to produce oxygen, and participate in the blue economy, and obviously help to shape all the fishery because they're apex predators. And the Caribbean, we're pretty lucky because there's more than 90 species in the world, and then we got almost a third of them, which is 33 species that have been seen in the Caribbean. This is a lot, like this is a hot spot. And we do need to protect them because it's a breeding ground and a feeding ground that we have here. There's a lot of babies that you can see around. And as you see, they're pretty important. But the problem is there's a big lack of data. And if you don't know how many is left, then you don't know if you need to protect them. And if you don't know threats, then you don't know how to protect them. So the map here on the side, so I don't know if, oh, you cannot see my mouth. So the one with all the color and all the islands, and with EC1, EC2, EC3 is the map of the distribution of the sperm whale. So if you listen to the sperm whale and then you hear them speaking different languages, you can check that they have 3 clans that have 3 different social units speaking different languages, and they actually go from an island to another without taking care of the frontier. And they would actually have different habits, different culture, like we have in the Caribbean with human. Like, for example, you have the French speaker, the English speaker, and the Dutch speaker in the Caribbean. That's exactly the same for sperm whale. And that's why also it's pretty important to do acoustics, to listen to them and to know where they are. So you can see also like a picture of like a dorsal spine from a dolphin in St. Vincent. So dolphin get hunted in some countries. And then if we talk again about the sperm whale or even the big whale, for example, a big whale will be underwater for like 3 hours and hub for like 5 to 10 minutes. So you can imagine how hard it is to spot them. Like they're always in the water. So it's really, really hard to get information on that. So again, you can see how complex is the situation in the Lesser Antilles, for example. If you're a little dolphin and you start, let's say, from Grenada and you want to go up, you're going to pass by, for example, St. Vincent or St. Lucia, where you might be hunted. Then you pass by a sanctuary where you should be protected, but there's still a lot of whale watching. Then you go out of the sanctuary, then you come back in another one. And then it's pretty like hard to see how a dolphin could recognize that now is protected, now is not. And there's like a big lack of continuity on all the rules and how to actually protect them over like a geographical scale, but also a temporal scale. So this is why we created the CCS. It's a local NGO, so it's the Caribbean Cetacean Society, and we try to actually have some continuity. So how do we work? Is we're trying to do some cooperation. So we try to make all the islands working together, sharing actually all the data. Then we do some research because, as you've seen, there's not enough data. So we do some scientific researching at sea in all the different islands to actually make sure that we fill in the gap of data. Then with those data, we can actually go to the government and then talk with them and make sure that we actually have effective regulation taking place. And obviously, we're trying to do some education. So we are not a problem like instead of fixing the problem, we're trying to actually make sure that we don't have that problem anymore, because the human is the main problem for the cetaceans conservation. So how do we do that in practical? So thanks to the help of our partners that you can see below, we actually conduct some surveys in 2021 and 2022, and we call that program the TWLONU program. And it's a cooperation, education, and research program when we have 6 expeditions of 15 days each year. So it's huge. Like it's usually 1 per year is nice. Now we've got 6 every year for 2 years, and then we're going to still do it. So the boat went from Grenada to Anguilla, and we had all the time the same protocols. And we use what is a visual transect. So it's a line transect with the boat. So you actually follow an imaginary line, and then while following it, you have 2 persons observing for the whales on each side of the boat. Then we also use passive acoustic monitoring, which is a towed array with 4 hydrophones. So it's basically a microphone that we put in the water. Then we can record the song of the whale, and then we can check if there's some or not. And then if there's some whales, then we can actually track them, for example, with sperm whale. And then we use another technique, which is photo identification, which it's basically like fingerprints. We take a photo of the dorsal fin of a dolphin or a fluke for a sperm whale, and then we can compare those photos, and then every fluke or every dorsal fin will be different. And then we can say, oh, this is George, and we've seen that dolphin George in Grenada before, and now George is in Guadeloupe, for example. So that's the techniques we're using, and it's pretty new to actually combine all of those together and to actually have them standardized all over the island. And with those techniques, what we can do is actually reply to some, answer to some questions. So what is the cetaceans diversity? Which species is where and when? What is the distribution, the relative abundance, and what are the threats? Because with the photo ID, for example, you can look at the scars on the body of the animal. So there's some results. You can see the tracking line in red of the boat, like all the place that we've been. And then you can see some density map, I think, for all the stations. So some islands have more, some islands have less. And this is only the results for 2021. We're going to have a result final, I think, by the end of the year. So it was the biggest survey that nobody had ever done in the region. And it was a great way to actually cooperate with the government, the MPA, the local people, the local biologists from all the islands. And we actually trained more than 150 people on the boat that we trained to recognize the species, the photo ID, actually how to monitor species with passive acoustic monitoring. And at the end, we had more than 400 sightings of 21 species, which is big results for marine mammal. But the bad news is when we analyzed the picture in 2021, more than half of the individuals that we took a picture of have actually anthropogenic marks. So they have a scars from a net or like from a fad or from a harpoon, and that show how the human impact them. And that's the one that's still alive, obviously. So how you guys could be involved in the next years, because I hope we got plenty people from the Caribbean right now. We actually going to continue those expeditions. So we still have, for example, WWF that's going to support us. And we know that in the next 3 years, we're going to still have those 6 expeditions and maybe even more in all the different islands. So you guys could join. So you have a QR code, or you can even contact me by email. And by the end of the year, we should have the dates for the different expedition. You can also complete a database. So we created a regional threats database. So if you see a strike, or if you see, I don't know, like some people selling meat of dolphin, all this kind of stuff, or just a dead dolphin in the water, just contact us and give us the information so we can make sure what happened. You could also get trained in one of the workshops. So we're going to train people to do photo ID, disentanglement, passive acoustic monitoring, and all the techniques. So if you're interested, just reach out again. If there's a goal after this, you can share your experience. So we're going to do some kid camps, and also you could join us in the team. So we do have internship for people. So what is the conclusion, the main conclusion? Because the problem is, how do we want to improve the conservation in the Caribbean? Like, what is the solution? We don't have one answer, but for sure, it's really important to cooperate. So it's good to have good tools, but if nobody's playing the game, then it's not going to work. Like you've seen, the marine mammal is going to cross all the islands. It's really important to build local capacities, because if we have people in the different islands able to do the research, then it will be actually easier to make it continuously. So you need to collect also the data at the cetacean scale. It doesn't make sense to actually do it on one island. You want to do it in all the islands. Education, for sure you need it. And then, yeah, again, keep it local. Make sure like we have people inspired and motivated in each island to actually do it. So I'm actually hoping that some of you would contact us by the end of the year. And I think, yeah, that's it.
Thank you so much, Jeffrey, for the presentation and telling us all about the Caribbean Cetacean Society. As always, you guys are doing absolutely amazing work. So I would open up the floor. Does anyone have questions? Feel free to just unmute yourself and ask away. If not, I can go first, but I would, you mentioned the internship program, right? So I want to know, when does that open? How do we apply? And what is that whole process like?
So we do have internship for master student, preferably, so long-term people. But if people are interested, we can actually contact and then have a chat and see how we could make it work. We can actually host people, and we have so many projects that we try to work on. So there's really space for a lot of people, but generally people contact us and then they're so motivated for 1 week, 2 weeks, and then they drop out. So that's why now we want people to come to Martinique and in our office, and then they can work for like 6 months, and then they really learn something.
Okay, sounds like a good plan. I see Robin is saying, asking if you could drop the contact information. Okay, you already did. And follow them on social media as well. That's actually where I believe I found you, Jeffrey, on social media, and you immediately responded. So you could definitely reach out. It's not an issue. So does anyone else have any other questions? I see people are saying thank you. Sounds interesting. Lisa is asking, what are your thoughts on whaling as a tradition, especially in places where the numbers are regulated, in brackets, and unregulated?
Well, that's a really interesting questions. So St. Vincent is the only island in the Caribbean which have a permission for whale hunting, and they have a limit of 4 per year with traditional catch. And there's a regulation. So that regulation should be according to the population estimate, so they should be good. A problem will be more about the unregulated fisheries or bycatch accident too, which happen in different islands. And in some place, and I would not name the islands because it's not the goal to actually say, oh, this is the shame of the island, but in some place, we do need the government or the fisheries to actually take action because there's sometimes 20 pilot whales or 20 dolphins that can get catch on the same day. And then we can understand that people need food to live, but first it's bad for them because there's a lot of mercury in dolphins meat. But second, it's also bad for the dolphin because if we don't know the population, I think we can actually lost some population and some social units. I hope it answered the question. Maybe not whole, but I don't think we have an hour to talk about it. Sorry.
But I also have a next question for you. Sorry. With all the data you've been collecting, have you seen it translated into helping develop policies within Martinique or across some of the other Caribbean islands?
Yeah, so like I was saying, the map, the result that you've seen is the result for 2021. And we're actually right now, like we had a meeting 2 hours ago to actually we're ongoing on the research, on the analysis, and it will be like a really deep report and really long report that we're going to translate in different languages. And it will be recommendation for each islands, for each government, because we do work actually with the fisheries and some government. So we're going to share our data and results, and we hope that we're going to be finished at the end of the year. It usually takes a year to do this, and we're trying to do it in 3 months, but maybe it work.
Okay, no problem. And I know Monique, who is one of our members from St. Lucia, who's supposed to be on the session today, but is probably very much caught up with work, participated in the last expedition. It would have been great if she could have shared her experience, but maybe we could have that for another time. But as I've been telling you, I would love to get some of our members to come across and join that. I just need to continuously keep lobbying SOA to hopefully get some funds to send at least, what is the maximum number of youths that I could send to join an expedition?
Well, there's no, well, we can, in each expedition can actually host 6 people from outside. And we have a minimum of 6 expeditions per year.
Okay.
So that's pretty much a lot. But as I say, I prefer to have like 2 or 3 really motivated people that would like to continue and that really want to go in this field than just people who just want to go because it's fun. And it's actually not fun. People need to know that it's really tiring and people get exhausted from it. It's a lot of work, to be honest.
Well, I could just imagine. I had one last question for you, but it popped out of my mind. Oh, look, Monique just joined. She would live very long.
Hi, Monique.
She is still joining. Monique, sir, okay, you have a next question.
Yeah, so for now, we've done it already on only from 2 years, and that's not enough data to track any change. We hope to be able to reply to this kind of question in maybe 3 or 4 years. But for now, our data set is not powerful enough to scientifically answer those questions. Sorry.
No problem. I'm Monique, sorry to put you on the spot, but if you're able to, is it possible for you to just share like 2 or 3 sentences about your experience on the last expedition with the Caribbean Cetacean Society? You can say no, but it will be great if you can.
Hi, yes, sorry, I can. Can you hear me?
Yeah.
Okay. Hi, Jeff. Hi, everybody.
Hello. How's it going?
I'm doing well. So how a brief way to describe the experience, it was amazing. It was really fun. It was very insightful. And you get a chance to interact with people that you might not have met otherwise. I've made a good bit of people that I can consider friends, family off of the trip. Being on the boat together for the 2 weeks was an amazing experience, but you also learn a lot. And at first, when you first get on the boat, it seems like a lot of little things to remember, but after a while, it gets really, really easy. And it's a great experience. So if anybody has a chance or wants to go into to do work with CCS, I highly recommend it.
Thanks so much for sharing, Monique. And sorry for putting you on the spot, but I could not pass up the opportunity to have you share. And like I said, hopefully I will be able to get some funding to send any of you interested in studying cetaceans, across to work with Jeff and the team to really get that hands-on experience. And we have one last question in the chat, and then we will move on to our next speaker.
Again, I will answer that question after the report will be out. For now, I prefer not saying something wrong. I'm staying on the scientific side, and I don't have the results next to me. So for now, I cannot answer that question yet. But stay tuned and then read the report. I think by the end of the year, it will be on our website. And again, if you want to join, there will be all the information. I think we're going to update the website by end of December or January. And you guys should find all the information, including the reports and all our fundings. So yeah, and then Monique, thank you for making me blush.
All right, so thank you so much, Jeff, and for your lovely presentation on the Caribbean Cetacean Society and answering all of our questions, mainly mine, but that's fine. And well, Monique, for sharing your experience. So we will move on to our next speaker, Brandon, who is from the Bahamas. Brandon, you can go ahead and share your screen and start your presentation.
Can you hear me now?
Sorry, yes, we can hear you.
Okay, so I will begin. Good afternoon, everybody. Today, my presentation will be on the ocean wave numerical modeling and artificial intelligence-based forecasting within the Caribbean Sea. I'm here in the University of the Bahamas, in the Bahamas. So the presentation will start from these 6 small chapters, but first we do an introduction. Now, ordinarily, the very first thing that people notice about the ocean would be its color, of course, because depending on where you are, maybe blue or maybe greenish or even a very dark blue. But other than that, the first thing that you really see and really notice and understand and appreciate about the ocean would be the ocean surface gravity waves that push and they pull and they take debris everywhere. They make surfing possible, and in some circumstances they may even be a threat towards coastal activities. So they are very important for coastal marine tourism, ocean engineering, maritime transport, even renewable energy, with the conversion of, let's say, the oscillatory motion of the ocean waves into electricity or even fresh water, and also climate change with regards to the exchange of gases between the ocean and the atmosphere. Now, traditionally, waves are studied using buoys or high-frequency coastal radars. Satellite altimeters are very important. But here we want to understand how waves can be represented within what's called a numerical wave model. That, of course, is very successful, has been so for the past, let's say, 30, maybe even 40 years. But only recently have we had the introduction of artificial intelligence techniques to study waves. And so this is where the presentation will generally revolve around. I would like to show you an event from subtropical Nicole just a few days ago here in New Providence. And so this would be on the northern coast of New Providence, upon which the capital of Nassau sits. This is an event where swell waves from subtropical Nicole propagated southwards to the northern shorelines of my island. And so as you can see, the damage that was caused, it doesn't look like much, simply because Tropical Cyclone Nicole wasn't so intense. But you can see that coastal communities are directly affected by wave activity, and especially because the notice to close these roads was not put out in time to prevent people from commuting either from the east or to the west upon this coastline here. So it is, of course, very crucial that we study these ocean waves and have a way to forecast the activity so that we can avoid situations like this or worse, simply because within Hurricane Dorian from 2019, this situation that you've seen here in this video was much, much worse. So we do want to have a variety of techniques to both study these wave activity under hurricane forcing, but also to be able to forecast what they're going to do, let's say within a span of the next hour, 2, 3, 6, or even 24 hours in some cases here. So moving next, I will briefly describe what an ocean wave model is. Essentially, you have a large-scale computer program that seeks to solve what's called the spectral action balance equation. And this is where different phenomena which guides and governs wave activity. So the first equation is the spectral action balance equation, but to the right-hand side where you can see the word S tot, this now can be decomposed into various components where S in would be the wave growth by the wind. And so, of course, when you have low winds over the ocean, you generally speaking have low wave height. But as the wind speed increases, those corresponding wave heights, of course, increase. Then after that, you have the nonlinear transfer of energy between a 3 and 4 wave interactions. That's a bit deep for the present conversation, so we'll ignore that. But other three very important factors would be wave decay due to white capping. And so when you're at the ocean, when you're at the coastline, and you see a white foam on top of the waves, this now is what's called white capping. And this, of course, has a very important implication with regards to the amount of energy that those waves may have, in addition to gas exchange between across the air-to-sea interface. But additionally, you also have wave decay due to bottom friction, so that when a wave propagates towards the coastline and it starts to feel the seabed, it also loses energy. And once that wave achieves a certain ratio between its steepness and its height, then they break. And that ratio would be about 0.142. I think it's, I can't remember the exact fraction for that, but essentially once a wave reaches that fraction, it then means that the wave will start to break. And again, that has very important implications for not just energy dissipation, but also gaseous exchange. And the third one would be the wave decay due to wave breaking itself. And so when you combine these various factors, you can then have an input on how a wave in a given area is going to be generated and how it's going to evolve over time. You also have other factors to consider in addition to the wind. Let's say currents. Ocean currents can also change the distribution of certain wave heights. So for example, if a wave is traveling in the same direction as the current, you're going to have energy leached from the wave into the underlying current. Alternatively, if the waves are propagating across against a current, then you have energy being sapped out of the current itself and into the wave, leading to a growth in wave height. So there are a variety of very exciting physical phenomena that go on when we want to describe waves, but especially when we want to describe them and examine them in a computer model. So an example of that is towards your right, where we have output from NOAA's Wave Watch 3 simulation. Without a doubt, they are the world's leader with regards to numerical wave modeling. But if you can carefully examine that figure, you can see that within the coastline, it's all white, which means that there is no data in those areas. So even though you can get a large regional scale examination as to what waves are typically going to be on that basin scale. You have no information on the coastline, where of course it really matters, as we saw in the previous slide. And so to overcome this issue, we have instituted our own wave modeling for the Caribbean Sea. Now, don't mind these numbers within this table so much, but these are the model settings, so that if and when you want to run your own model, you can follow what is shown here to get some very, very good results. Simply because the work has been done already, has been validated using a variety of methods, inclusive of buoys and satellites, so you can have confidence in the results being shown. So here, as previously mentioned, the waves within both the region and across the world are governed very largely by atmospheric circulation. And so the figure towards the left, you can see, would be the mean surface wind speed derived from a satellite altimeter. So these wouldn't be model results, but these would be satellite observations of what the wind speed is going to be. As you can see, and this is from 2010 to 2019, as you can see that within the Caribbean Sea proper itself, the wind speeds, of course, are very high, and they may range anywhere from, let's say, 8, 10, or even 12 meters per second. Now, of course, this is not the case during hurricane situations, but generally speaking, the wind regime within the Caribbean Sea is governed by the Caribbean low-level jet. You, of course, have a few other atmospheric features which may influence that jet, where maybe more intense or weakened throughout the year, which then gives rise to what's called a bimodal distribution. And so the highest wind speeds, they occur in about January, February. That's one bimodal high, but then you have a second one in about June or July. And then you have lows within the spring and the fall. So essentially, you should, if this is what the distribution of wind speeds are going to be like, then your distribution of waves should also be similar. Now, once you understand that there is a very strong connection between the surface winds and wave height, that then allows you to establish an empirical statistical model between these two, so that if you are given observations or even numerical simulations of the wave height, it therefore means you can estimate what the corresponding wave field is going to be like. And that was the idea behind work that I have done last year. So you can see from the right figure that you have Hurricane Dorian from 2019 that affected the Bahamas. You have its wind field, okay? And so we also plotted a 9 meter per second contour. Now, unfortunately, the model is limited in that it only works under hurricane conditions. It can only have good, sensible results once the wind speed is over 9 meters per second. So when you have that wind field and you have a corresponding wave height baseline from, again, the previously explained wave watch 3 model, then we can use the equation that appears above that figure to convert the surface wind field in figure A into the corresponding wave field for C and D. Now, what is interesting is that these models, they're very widely used. And so the previous state-of-the-art was a South China Sea model that was produced by Niu and Feng in 2001. But you can see very clearly that due to the yellows and the green within figure D, it doesn't match the wave heights within figure B, which is the wave watch 3 baseline, what we establish as the standard. But once we institute a new model using data directly from Hurricane Dorian, we can then see that the Caribbean Sea model is, it's the magnitude of its generated wave heights are much more similar to that of those from Wave Watch 3. But you may also notice that its spatial distribution is not identical to that in Wave Watch 3. It is identical to that in the surface wind field, and that is because the only dependence that these estimations have is on the wind field. So it will take the exact same shape. While we have good numbers on the magnitude, we don't have the spatial distribution. That's okay, but it is not ideal, simply because those waves then interact with different islands, or let's say the different morphologies of coastlines. We can't get that spatial information from an empirical model like this. So we actually have to now institute our own model. And that is what we're doing here in the next slide. So when we take the output from the simulating waves at nearshore model, one that has a significantly higher resolution than the publicly available WaveWatch3 dataset, coupled with a very high resolution bathymetric dataset, we can then begin to see that wave features within the Caribbean Sea, and in fact throughout the Western North Atlantic, where the Bahamas is, that wave features are a lot more, they're more exciting when you view them this way, simply because the wave shadows that you can see, let's say in the left figure, within let's say in the southeastern coastlines of Cuba, or the eastern coastline of Hispaniola, and even to some extent, to a very small extent, along the Lesser Antilles, but the greatest extent, of course, is seen within the Bahamian Islands towards north of Cuba. You see that wave sheltering effects are very pronounced, and this simply means that within when you have very, very small islands, there's a very small difference between, let's say, the leeward or the windward side of an island in terms of what the wave distribution is going to be like. But for larger islands, such as Cuba or Hispaniola, then wave sheltering effects are much more pronounced. But you can still see within the Caribbean Sea proper that the highest wave heights, they occur naturally directly under the Caribbean low-level jet. And of course, that is intuitive, because when you have high wind speeds on the ocean surface, it then allows for a high wave growth. But what's interesting here is that when you couple a high resolution wave model with, again, a high resolution bathymetric data set, it then can allow for the examination of how those waves interact with the Nicaraguan rise. That is a very shallow water shelf that occurs just off the coast of Nicaragua. So if you look between about 85 degrees west and 75 degrees west, you see that the distribution is not, it's not a round shape as you would expect from the distribution of wind speeds in the previous slide. So this is a lot rounder, but here, because of the presence of the Nicaraguan rise, in addition to a very large number of islands in the Western Caribbean Sea, that distribution of wave height is different than that of the overlying wind speed. So that when you have, let's say, ocean engineering activities, if you wanted to install offshore wind turbines, it then means that when you put these turbines under areas of high wind speed, the wave height, the distribution of wave height and the pattern of wave propagation would not necessarily be the same as the wind direction. And so when you have a difference between these two, it then means that you have more stress being put on the wind turbine, which increases your costs for operations and management. And it also has important implications on the efficiency of the wind turbine entirely. So these simulations are extremely, extremely important. And so you can even see that explaining the, well, demonstrating the close connection between the Caribbean low-level jet and wave heights within the Caribbean Sea, you'd find that, of course, as I previously mentioned, that from figures C, D, E, and F on the right figure, you'd find that generally speaking, right, you have the highest wave heights occurring within the winter months of January or February, and in the summer months of June and July, but then the lowest wave heights appear within the spring and the fall. And so this is identically coincident with Caribbean low-level jet activity. But this is not the case within the Atlantic Ocean. Of course, that the Atlantic Ocean now is insulated from the effects of the Caribbean low-level jet due to the Greater Antilles Islands of Cuba, Hispaniola, Jamaica, and Puerto Rico. So that for us in the north, in the Bahamas, we are more affected by the occurrence of swell. Now, swell is to be distinguished from wind waves, which wind waves are those that are generated directly under wind action. But swell, by contrast, these are waves that are generated from a far distance away to then propagate towards your coastline, and in doing so, they undergo a very remarkable change in their physical structure. So that the pattern of high wave heights, high and low wave heights within the Caribbean Sea and the Atlantic Ocean are very distinct. And that will have, again, important implications for, let's say, for climate change sub-regional climate change. It also have implications for renewable energy things that you want to do. And so when we have these models, it allows for us to get information on a sub-regional scale that is not currently available in the publicly accessible global wave models. So we can, in the previous slide, we've talked generally about the significant wave height. Now, this would be inclusive of wind waves and swell wave component, that both of those together. But when we separate out the swell wave component, we'll find that the patterns would, of course, be indicative of the local wave regime. So when you, to the left, this is a bathymetric and topographic map of the region that the model had run on. And from there, I extracted data from two locations. One was NDBC, which stands for the National Data Buoy Center, buoys within the Caribbean Sea, but you have one for 41043 and the other one for 42058, which respectively are in the Atlantic Ocean and the Caribbean Sea proper. And you can see from the right figure to the top that the swell waves, of course, account for a minority of total waves within the entire region. But when you compare the top figure with the bottom one, then you can see that the proportion of swell within the Atlantic Ocean is a lot higher than that of the Caribbean Sea. And that, of course, is very intuitive, simply because the Atlantic Ocean is wide, it is open. You can have waves traveling from every different direction to then have a change in nature from the wind waves where they were generated over into swell. So by the time that they reach us here in the Lucayne Archipelago, we get more swell than we do get wind waves, but wind waves still dominate overwhelmingly. In the Caribbean Sea, by contrast, because of its semi-enclosed nature, swell has a very hard time propagating in from the Atlantic Ocean, of course, because it is hampered by the Greater and the Lesser Antilles. So when you couple that with the influence of the Caribbean low-level jet, you, of course, will find that the wind waves, yes, they still dominate, but the proportion of wind waves to swell is much higher than within the Atlantic Ocean. And this is something else that has been revealed through the high-resolution numerical wave modeling. This would be a spatial map of ocean swell wave height. Now, again, we see that within the Atlantic Ocean, throughout the entire year, you have the highest swell waves within the winter, fall, the winter, fall months. And this is due large in part to the occurrence of extratropical cyclones, but you also, of course, have a small component of the residual effects of hurricanes that come through the entire area. But because hurricanes, they occur only on scales of a few days, the signal that they have cannot be readily observed when you have 10 years of data as is done here. But one interesting feature is that within the Caribbean Sea, over the Nicaraguan rise, which of course would be towards, let me see if I can pull up the marker. So if you can see here, in all of these locations, this would be the occurrence of the Nicaraguan rise. And so when swell is generated on the eastern side or even the central Caribbean Sea, they propagate towards the west to then impinge and be absorbed and reflected by the Nicaraguan rise, so that, again, your wave conditions within this area, they would be very, very different from what you would expect from the distribution of the wind speed or wind direction. And so this is a very important aspect of the wave climate within the Caribbean Sea, simply because this has not been previously studied in prior studies. And so this, again, highlights the importance of coupling a high-resolution wave model with equally or even higher resolution bathymetric data sets. This, of course, would be very important, again, to climate change research, maritime transport, and again, ocean renewable energy, inclusive of wave energy installations and offshore winds. So moving on, we can actually show an example using Hurricane Matthew from 2016. We, to the left figure, you have a 3-day composite of the swell wave heights within the Caribbean Sea due to Hurricane Matthew. And you'd find that the highest, figure A would be the wind waves, and then figure B would be the swell. You'd see, of course, that with regards to wind waves, of course, they're everywhere, and that's to be expected. But the distribution of swell in figure B is much more concentrated only within the Caribbean Sea. And again, that is due to the Greater Antilles Islands, and of course, in this case, Cuba, Hispaniola, and Jamaica, keeping those waves from propagating up further northwards towards the Bahamian Islands and the Turks and Caicos. But what was interesting here was that even though Hurricane Matthew occurred within the Central Caribbean, and then immediately after reaching about 75 degrees west, it then went northwards to cause a great deal of chaos for us in the Bahamas in 2016, you can still see that for the location marked by NABC 42056, that the signal of that event could be felt, even though it's 1,200 kilometers away. And so if you were to go and access data from that particular buoy, you'd see that between September 27th, and this is, of course, the right figure, between September 27th and about October 1st, the dominant wave period, which signifies if this is swell dominated or if it's wind wave dominated, and if you are high frequency, so every 4 seconds, 6 seconds, you have a wave coming along, and this would be a wind wave. But you would see that on October 1st, at around midday, you have a sudden spike of much lower period waves, and these lower period waves, they used to be the ocean swell radiating out from Hurricane Matthew, and that lasted for almost a whole week. And so you can imagine that if you were on the, let's say, the western coastlines of Cuba or the eastern coastlines of the Yucatan Peninsula, you should be generally safe from Hurricane Matthew. And the simulations show you that even in these locations, you are not safe. These waves have the ability to travel thousands and thousands of kilometers away from their point of origin with all of the energy that they started off with. And so when we have these simulations, it is very crucial that different countries within the Caribbean have these capabilities to run these models on such resolution, and also have the capability to monitor these wave conditions both in real time and have a very large archive of what past wave conditions would be, so that when future events occur, we can have a pretty good understanding of what things are going to be like. Now, that then brings us to this next issue, all right? One of the challenges for us in the region is that we lack the technical expertise, we lack the computational resources, and of course, during a hurricane condition, we lack the time to run these numerical models. And one way around that would be to introduce artificial intelligence methodologies. And within my own research, I, along with my team back in China, we've been using the long short-term memory network for wave forecasting. Now, the characteristics of it is that it is a recurrent neural network, and specifically LSTM also allows for long time series to be remembered. All right, so it remembers important information. It allows it to remember important information both on long scale while forgetting less important short-term information, but it can pick and choose which information that is saved, so that we then want to move forward from this and use the model to predict the wave heights both on mean states and during hurricane conditions. So for us, we set up LSTM using model-validated significant wave heights, and we've given it a training data set from 2016 to 2019, but we then have a test set of 2019 that was not included within the training data to ensure independence of the model. The activation function would be the recursive linear unit. That's not very important for now. Epoch's 100, again, not important. Batch size 100, not very important for now, but it makes sure that the model does not, it is not subject to overfitting, so that it will learn a pattern, yes, but it is not too generalized where it can only copy that same pattern over and over again, but it can learn general trends. And so when wave heights tend up, then it will start to forecast waves going up. But if it's going down, it'll forecast waves going down. So moving forward, we have extracted one location from the Central Caribbean Sea for testing. Now, these simulations, these forecasts, they are only using test data of significant wave height. So you find that, generally speaking, regardless if you start from from 3, 6, 9, or 12-hour forecast, that the model can maintain an accuracy of 0.92 or higher with a very, very small root mean square error. And so when you have the ability to predict waves far into the future with an error of less than half a meter, this means that your model can be very effectively utilized within a variety of applications, inclusive of storm conditions, but in this case, mean states, so that let's say when you're doing renewable energy and you want to know, well, how many waves are we going to expect within the next 3, 6, 9, 12 hours, which would then correspond into how much energy we can get from the system. We can properly plan and manage our operations so that we can minimize costs and we can balance the grids. But what you can notice, of course, is that within January and between June and July, you have a sudden decrease in LSTM's model to accurately predict what the wave height is going to be at its most extreme. Now, that is because the model was only fed information from wave height. It was not given an explanation as to what the overlying atmosphere is doing. So its ability to predict extreme wave heights minus information on the wind speed, right? It then deteriorates the model's ability to forecast these events into the future. So if we now look at we take six locations throughout the region. We have 4 within the Caribbean Sea and 2 in the Atlantic Ocean. You find that from the red lines in Figure A, the accuracy, the forecast accuracy, it decreases over time as to be expected, but it's still much higher than other locations. And these 42056 and 42057, they are very close to the Caribbean low-level jet, but they are, and this is crucial, not directly under the Caribbean low-level jet, where certain bursts of extremes would then lead to the model being unable to catch up, and it would, of course, lead to a deterioration of how well the models can predict these wave heights. But you also see that from the blue lines in A, from 41043 and 41046, that these forecasts are very strongly influenced by Hurricane Dorian. And even though Hurricane Dorian was just a few days, and this would be forecast on a mean state, which when you would imagine that a very high frequency event, even though it's very, very powerful, shouldn't have a large effect on wave condition forecasting for the entire year. It is still very heavily affected, simply because when you take out a small segment of data or you add in a small segment of data, whatever you fed this model will have a very strong impact on what the model is going to do. So you have to figure out now, how can we minimize the effect of these hurricanes on the mean wave state forecasting, but then how can we maximize the effect of hurricanes when we want to focus on hurricanes? And so that focuses, that brings the focus of purely using AI models to forecast wave conditions under these conditions. Now, we have taken several hurricanes that occurred within the region from 2010 to 2019 as a training set. But in this case, we take both the buoy observed significant wave height coupled with a corresponding wind speed to have one joint model that can be used to predict wave heights under hurricane forcing. Now, from the left figure, you would see that these would be the hurricanes that we used both for the test and training data sets. But an example is given from the right figure where we examine how, let's say, the AI methodology LSTM can be used for predictions in comparison with SWAN, which is a numerical wave model. And so what was very interesting here is that when you look at the blue line, which is the observations, the red line now would be how LSTM, the AI model, would forecast those wave heights between the landfalling of Hurricane Dorian within Abaco, Bahamas, over the next 10, 20, 30, up to 60, 70 hours. And of course, you can very clearly see that the model is remarkably good at following the observations, where the numerical wave model, by contrast, only gets to approximate the observations only after the first 30 hours once the hurricane made landfall. Now, you can't wait 30 hours to know what the wave height is going to be, like under hurricane conditions. And so, of course, under these circumstances, your best, and I think your only option now would be to use an artificial intelligence methodology, simply because it gives you high accuracy, very high accuracy, but also immediately. It doesn't take a large amount of data to run this AI model. It also doesn't take a lot of expertise. It doesn't even take a lot of computational resources. This program was run on my personal computer, where the model, by contrast, the SWAN model, had to be run on a very, very large multi 100 core machine that costs a whole heap of money. So with regards to using AI techniques versus the numerical models, especially under hurricane conditions, there is no choice. You want to use an AI model. So some of the future research that we want to conduct here would be to look at how waves and currents affect each other. So from the left figure, you would have the mean surface current velocities within January 2019, and so very clearly within the Caribbean Sea, the sub-box D, you have the Caribbean current, which of course propagates from the east in the Les Antilles throughout the entire Caribbean before traveling upwards towards the Yucatan Basin, which then is converted now into the loop current within the Gulf of Mexico, and that's A. Then in B, you have the Florida current through the Florida Straits, before then converting again once more into the Gulf Stream. Now, as I previously mentioned, in addition to the wind speed being a major factor for the distributions of waves throughout a region, the waves are also affected by the current velocity and the current direction. Now, unfortunately, I did not put the directions here for you, but you can see that within the D box on the right figure, waves are propagating from the east towards the west under the influence of the Caribbean low jet, so that is also in the same direction as the flow of the Caribbean current. So that wave heights are actually suppressed because energy is being absorbed from the waves into strengthening the current. But that's within D. If you are within the Gulf Stream, by contrast, so in this situation, the current velocity would be pointed towards the north along the Florida coastline, but the wave direction now is pointing in the opposite direction, coming towards the south, towards the Bahamas, so that energy from the current system is being input into the growth of the wave heights. So you see that the change in wave height within the second figure towards the right, the percentage change is much greater, of course, within the Gulf Stream, as opposed to the Caribbean currents, and this is simply due to the difference in directions of the currents and the waves in these various regions. Moving on from that, while we have very good tools for numerical wave models and for artificial intelligence methodologies, they both have advantages that we want to keep, but then they have disadvantages that we want to try to eliminate. And so what we will do is to build a new wave model that has all of the physics that a numerical wave model is characterized by, but also in an artificial intelligence framework, so that we can have the speed and the cost effectiveness of these models into one joint coherent model, so that we can within the region have a very precise wave forecast done, minus the computational expense of these systems, and very rapidly. And of course, during hurricane conditions, as we've seen most recently with subtropical Nicole, knowing what waves are going to do under hurricane forcing is absolutely critical to your coastal and maritime tourism, coastal and marine tourism, to your maritime transport, to your ocean renewable energy. There's a variety of applications for these systems. And so we definitely want to invest time and effort into generating what's called a physics-based artificial intelligence forecasting wave model. I would like to thank my colleagues in China, simply because I've just graduated, I've just come back. So we want to give support to Professor Chang Mingdong at the Nanjing University of Information Science and Technology. Of course, the Chinese government and the members of the ocean modeling and observations laboratory. This is the list of references. Now, we have 2 published works in this area so far, but then there's another 3 that are still being prepared and will be submitted for review in an SCI journal, hopefully within the next year or early next year. And thank you very much.
Thank you so much, Brandon. Wow, I feel like you took me back to my physics days. And it was so detailed, and you explained things so well, and it was so in depth, and it's a very interesting field that you have found yourself in. And I know some of the participants are also very interested in the work that you are doing. So please, we unfortunately don't have time for questions right now, but maybe at the end if there is time. So if anyone does have any questions, you can drop it in the chat. There is one in the chat for you already, and please do share your contact information with the participants, as well as if any of the papers are open access, then also drop that in the chat for us to read more. Very, very interesting research and work that you have going on, and we will stay in touch to see how best we could keep up with you on everything that you have doing. So moving on to our next speaker, I'm seeing great presentation, excellent, congratulations. So it was, like I said, very informative. But moving on to our next speaker, we have Michelle, who is a sea turtle biologist and conservation specialist. So Michelle, the floor is yours.
Hi, good afternoon, everyone. Thanks very much for this opportunity again to be involved in this. Some great presentations so far. Let me just, yeah, okay, great. So yes, as Khadija was saying, my background is in sea turtle biology and conservation. I did my PhD at UE, and I'm a director of the NGO Species and technical advisor to Save Our Sea Turtles Tobago. And today what I was thinking is I would love to tell you a bit more about sea turtles, in particular some of my research here around the island of Tobago, and then touch on some of the aspects, some of the applications of technology in sea turtle research and conservation. So all around the world, there are 7 confirmed species of sea turtles. Of course, they share a lot of similar characteristics, being that they spend so much of their lives at sea. They return to nest at nesting beaches, but yet they have different patterns of in their life cycle as well, including very different diets. So why are sea turtles important, and why are we concerned about their conservation? Sea turtles, through their diet in particular, really contribute to healthy marine ecosystems and healthy marine food webs. Some of the species have very unique diets that no other species do. So, for example, green turtles are herbivores, foraging on seagrass as well as algae. And their continuous foraging action actually helps increase the productivity and health at seagrass beds. It helps keep the coral reef free of algae that might overgrow it. And some of the other species as well have similar ways, unique diets that really help contribute to healthy marine ecosystems. Many people don't think about this, but also the way sea turtles reproduce and produce so many eggs and hatchlings on the beach, those eggs and hatchling actually serve as prey to other species. So there are a lot of other species that depend on sea turtles as a source of food. And all of that is an important role. They also can contribute to nutrient cycling throughout the ocean and our marine ecosystems, uptaking nutrients wherever they feed, be that on a reef or seagrass bed or further offshore in pelagic habitats, and then returning some of those nutrients to beaches, where it can be an important contributor to healthy dune vegetation on beaches. So I want to talk a little bit about the life cycle of sea turtles. This is a generalized life cycle that applies to most of the hard shells species like hawksbill and green turtles. If we start out at the nesting beach, we have the hatchlings dispersing to open waters. That initial stage drifting offshore, far offshore from our beaches, is sometimes termed the lost years because we know so little about it. It's a very challenging part of their life cycle to study because they are so widely dispersed and so far from shore. And so much so that we know little about even how long that stage is, but there's more and more evidence showing that for most species it might be on the smaller scale of this, like 1 to 2 years time. Then they have what we call a ontogenetic shift in their lifestyle. They go from living at the surface of the water far offshore. They now move into coastal waters, where they have a complete shift in diet as well. They are now diving down and spending most of their time at the bottom of the sea, where they will feed and so on. So at this point, this location can be far from the original nesting beach, right? Because they've been drifting far offshore and then they recruit to some other reef habitat. So what we find is that any reef or nearshore habitat where you find sea turtles, the majority of those turtles have not originated from a nearby nesting beach, but will be a mix of individuals drawn from all around the region where you're talking about, right? They will stay in this juvenile and subadult habitat for quite a long time, resident in quite a small area, on the order of a few kilometers maximum, really. And then they have, once they reach maturity, we see another shift where they make a shift to an adult population, right? So in areas where you find a lot of juveniles, you don't tend to see a lot of adults. Adults will be usually in a separate location, but it will be a similar type of habitat. So if they were living in a reef, they're probably shifting to another reef, but it might be deeper, further offshore, right? This maturity change, again, happens. We know very little about when it happens. We're learning more and more from various types of studies of tracking turtles and doing genetic studies and so on. And for some species, there was data showing that it takes them as many as 40 years before they achieve sexual maturity. So sea turtles also share this long late maturity pattern and very long lifespan that they have, okay? Again, more and more evidence coming in. So these estimates are shifting. There's some data that shows that for hawksbills, it actually might be earlier, like 10 to 15 years, but for green turtles seems a bit longer, right? From that adult habitat now, which again is quite far away from where these turtles were born, they start making these nesting migrations. Females do these migrations every 2 to 3 years. And we have data again from genetics, primarily showing that the females actually will be able to retrace their steps in a way, but not necessarily the same path, but they are able to navigate back to or very close to the nesting beach where they were born. So this is a characteristic called natal nest site fidelity. They're faithful to the nesting site where they were born. Males is a little more of a mystery because, you know, we can study female turtles when they come to nest on the beach, but we don't encounter male turtles very much. But what data we do have is showing that the males don't share that same pattern. They may go to just a nearby nesting beach close to where their foraging grounds are. So they don't have to make such a long migration as the females, and they can potentially nest more often every year. Right? Another key life cycle characteristic and pattern that most of the sea turtles share, all of them really, is this survivorship graph here, right? That we have starting at the left with, you know, thousands of eggs. From those eggs, not all are going to survive. So we have some loss. Then we have the hatchlings leaving the beach. They are attacked by their natural predators on the beach. We've got seabirds, vultures. In some places you'll find species like raccoons and so on that might, crabs even can attack juvenile hatchling turtles. When they leave the beach, they face more challenges from predatory fish, barracudas, sharks, dolphins, as in mahi-mahi, right? So naturally, without even looking at the impact of humans, naturally we know that there's this high mortality rate of eggs and juveniles. It's only as the sea turtles get larger and larger and attain adult size that they are now protected from predators. There are not many natural predators that can successfully take an adult turtle, all right? Because they're so large, they have their protective shell, they're very agile in the water. So once they reach that adult stage, naturally they have what we call a high adult survivorship. They are typically going to survive a long time, barring any threats or unnatural impacts that might be that they might face. Right, and this is a common estimate that you may have heard, that only 1 in 1,000 hatchlings may survive to maturity. And again, that is the natural ratio of success. And this is just one of the possible strategies that you see in wild animals. You know, you can have species like fish, turtles, and so on that mass produce their eggs. They know that there's going to be a lot of mortality in the beginning, but they produce enough to compensate for that loss. The opposite strategy would be having only 1 or 2 offspring, and then you are able to invest more protection and care into those couple of offspring to make sure that they survive. Right, so of course with conservation of any marine species, the better we understand their biology and ecology, the better we can understand how to manage or conserve them, right? So it's very important that we have research in different areas to help us understand these, you know, these patterns of movement, the natural threats they face, the anthropogenic threats they will face, and so on. But it can be challenging to study these sea turtles because of some of the characteristics I was mentioning, including how migratory they are. They travel thousands of kilometers across the Caribbean Sea. Even leatherbacks will travel something like 12,000 kilometers between their foraging habitat and nesting habitat. They have these major shifts in habitat, so you can't just monitor them and conserve them in one of those habitats. We need to learn more about where they spend their time and you know, really understand those shifts that they have. They're also solitary creatures, so it's not like you typically find a high aggregation of turtles that you just go to one location and you could study them. They're widely dispersed across the sea. The only time they can tend to congregate is during breeding. Right. Again, this high mortality of young, low mortality of adults. An example of why this is an issue is if you want to study young turtles, you have to study a lot of them, because chances are most of them are going to die very early on, and you will not get a good sample to see how they are spending those first few years of life, right? Long life and delayed maturity, that means that we really have to study them for a long period of time as well to better understand the population and detect changes in the population and so on. Slow reproduction rates, which makes them vulnerable as well to lots of threats, right? So even though they produce so many eggs, overall, because of the mortality, they can tend to have slow reproduction, right? And all the sea turtle species around the world are considered threatened. Certainly the 5 species that we have here in Trinidad and Tobago. And this is primarily after heavy exploitation in, you know, the 16th and 17th centuries primarily, all right, especially in the Caribbean. That is when we had a lot of heavy exploitation targeting turtles for meat products primarily. So they are already vulnerable because of their populations are so small, and that also makes it more of a challenge to study them. Right, so I now wanted to cover a few examples of the research methods and really focus on some of the new and interesting technology that can be applied to marine turtle conservation. So these are some of the ones I'm going to be talking about. So tagging, and by tagging I mean passive tags, which would be usually a small plastic or metal tag with a unique ID number that gets placed on turtles, usually on the front flippers for hardshell turtles or the rear flippers for leatherbacks. And that is a way that's typically used to passively monitor sea turtles at nesting beaches, and has been now used at foraging grounds as well. So this tag only gives you information when you have another encounter with the turtle. You have to tag it and then wait and see if it returns to the nesting beach. If you encounter it again on the foraging ground, whatever, then you can identify the turtle and learn more about their growth rates, etc. So this is a long-standing, pretty basic method that yields great results, but it's been used for a long time and might be the method that most people are familiar with when they think about sea turtle conservation. Then we have tracking, and there's various types of trackers. I'll talk about 2, including satellite tracking and acoustic tracking. And this is where you have an actual electronic instrument that helps you track the whole path of where it travels, right? So that we learn a lot about migration routes through things like that. We have data loggers. These could be data loggers attached to turtles in the wild while they are swimming around as well, to log information, things like the depth that they dive to, how long do they spend submerged, how fast can they swim, right? Genetic studies are very useful in looking at the population genetics, meaning examining different populations that we have, how connected are they to one another, how much genetic mixing is going on. It can even help you make population estimates of how many turtles you have if you do a detailed enough sample of individuals. Citizen science is sort of an emerging tool in conservation in many ways. And we have Species as recently starting a citizen science project. So I want to tell you a bit about that. Photo ID is a form of technology looking at identification of individual turtles based on photos, and it's based on primarily the pattern of scales on the face of the turtle. So you'll see that in the bottom right picture there. By measuring, by taking enough photos of different turtles, we can get data on, we can identify different individuals then. Sorry for the typo at the end there. The last one would be drones or UAVs, which can be used in some interesting ways to monitor sea turtles as well, right? So let's touch on a few different aspects. So first I wanted to tell you about my PhD research in Tobago, the method I was primarily using, well, I was studying hawksbills and greens found around Tobago, offshore, primarily on the coral reefs around Tobago. So I was using scuba diving to get in the water and monitor them. We would hand capture the turtles where possible, bring them to the surface where we could tag them, collect data about their size, and take samples for some genetic analysis, which I will touch on as well. So I sampled about 235 dives I conducted at these 40 different dive sites around the island. Those circles you see in blue are locations where we detected hawksbills, and red are locations where we detected green turtles. The size of the circle indicates how frequently we encounter the turtles. So we got some information about, you know, this site in particular I would highlight as the highest frequency of encounters, that quite far offshore Tobago, but a shallow plateau with rock ledges that the turtles like to venture underneath. And this area here, whereas, you know, hawksbills were most common and widespread, this area was particularly important for green turtles. Overall, I will just give sort of summaries as we go. So overall, we found that we had primarily juveniles, right? So remember I said that juveniles and adults tend to live in separate locations. We have primarily developmental habitat for juveniles. Some mature ones were encountered, but they may have been just passing through for breeding purposes. Hawksbills, their primary diet is sponge, and they were more abundant at sites that were dominated by sponge in general. And we found that they're living quite far offshore too. They're not limited to the small fringing reefs around the edge of the island. As I mentioned, that one site where we saw most of the turtles, this is a photo of it at the bottom right, where you can kind of see some of the rock ledges. And this seems to be important habitat that hawksbills like. They're able to sort of rest underneath the ledges. This protects them from predators. It may help them conserve their energy because they can kind of wedge themselves in there and don't have to fight the currents and their buoyancy and so on. And importantly, green turtles were previously really thought to be only found at seagrass beds around Tobago, but we found green turtles, you know, well, reefs are important habitat for green turtles as well. Right, so the tissue samples I would take, we applied a method called mixed stock analysis by looking at mitochondrial DNA. Now, mitochondrial DNA is separate from your chromosomal DNA. It's a form of circular DNA that's located in your mitochondria, which are part of your cells that deal with respiration and creating energy. And this DNA is passed down through the maternal line. So down the family tree here, you see the female passes it on to her son and her daughter, but only the daughter then passes it on to her offspring. And there's no recombination happening here and so on. So this happens with no changes down the line unless, you know, you can get randomly mutations appearing. So over long time frames, you get these little mutations that may be unique to different populations, right? And so what we do is we survey a particular region of that mitochondrial DNA that tends to be very variable. In this case, we looked at up to a length of about 800 base pairs. And so this is an example of what a haplotype looks like, these letters at the bottom here, right? Our DNA is made up of these bases, A, T, C, and G. And this combination, this pattern of them is, each unique combination or pattern is called a haplotype. So the same region of the DNA we're looking at, due to mutations, can have different patterns, and therefore it's identified as a different haplotype. What we do when we get the haplotype data, we look at the haplotype frequencies at different places. So we look at how common is each haplotype in each of the rookeries, which is your nesting populations, and your mixed stocks, which are your foraging grounds that represent a mix of individuals from different rookeries, right? And we put this into a model and run some statistics that I won't get into the details, but you look at the frequencies from each of the rookeries labeled R, as well as each of the foraging grounds that you have data for. You can include information like the relative rookery size. So you know that some rookeries produce a lot more individuals than other rookeries. And that helps you estimate where your turtles are coming from. Because there are some unique haplotypes that could tell you right away, once I see this haplotype, I know it came from, let's say, Puerto Rico, but there are a lot of very common haplotypes. And so it's the ratio of those, the frequency of those that we're looking at to help us estimate where the turtles are coming from. So this map shows you the different major hawksbill rookeries that that at the time I did this work would have had data available, right? So it's not, does not include all the rookeries around the region, just those where we have data. And you'll see here about 19 different haplotypes represented by the colors. So each color is one haplotype, and you can see that there are two dominant haplotypes, the kind of green color that you see here in Antigua, Barbados, Brazil, and up here in Cuba. And then you have the pinky purpley color of Puerto Rico, USVI, Barbados, Belize, Costa Rica. So those are the more dominant haplotypes that are quite common and widely distributed, but they are limited to only certain islands. And you tend to have one dominant with one or dominant with the other. And then we have some more unique ones, like this red one coming from Mexico. Right, so when we ran our mixed stock analysis, these are the results for the Tobago mixed stock. These pie charts show us the fraction of the population from Mexico that is coming to Tobago, for example. So if you look for this sort of orangey color, we can see it's just two small slivers we've taken out and sent to Tobago, and that equates to together almost a quarter of the population on the Tobago leeward side and the windward side. So just to point out, we have two circles because we actually found that there was some differentiation between the aggregation on the leeward coast and the windward coast. There's some differences in how many turtles we have from different places, okay, which we haven't been able to explain, but it's an interesting observation. So you can kind of see that Cuba is a major contributor. There's these two large slices coming out of Cuba that are found both on both coasts of Tobago. Barbados and Puerto Rico are also important contributors. And this is, you know, partially related to the size of these rookeries. These are some of the larger rookeries which do produce more individuals. But it highlights the importance of this work because it highlights the regional linkages. So we know, for example, while Cuba, Barbados, and Puerto Rico are some of the major contributors to our Tobago mixed stock, these actually only represent a small fraction of their populations. So if we're harvesting sea turtles around Tobago, for example, the impact of that harvest will not be felt necessarily at those three large rookeries because they're so large, but it will be sort of more distributed throughout the region because we do have individuals coming from so many different places, right? And I will mention when I started this work, we had a legal sea turtle fishery in Tobago, but that has since been closed, though we do still have poaching as a problem. So, and then the Tobago rookery, I was also able to get samples from the nesting beaches with the help of SOS and a group called Nest. And that showed that that rookery is also considered genetically distinct from all the other rookeries that have been described in the region or characterized. So it is an important management unit. And we did have some unique haplotypes detected at the northeast coast in particular. So it shows that we have differences at each beach, right? Or each part of Tobago has important genetic differences. And in order for regional conservation, it demonstrates the need to conserve all our beaches and not ignore any of the, smaller beaches and so on. Right? We did have a strong link that we have major contributions to both Cayman Islands and Puerto Rico. right? So moving on now to the citizen science. This is a project that Species and SOS have partnered on and recently, well, we're kind of preparing to launch. We have some funding. We're getting ready to do a national awareness campaign about this project. The idea of citizen science is really you're engaging with members of the public to help you collect information. And in this case, we want information on where are the turtles found around Trinidad and Tobago. Are there important habitats that should be identified and protected, and where we could go to study turtles in more detail? You know, because me as one person, as a researcher interested in turtles, I don't have the means or the resources to go and dive everywhere or to go and survey all our offshore environment. But we have fishermen, we have yachties, we have snorkelers and divers, and people who enjoy going to the beaches and being around the water, even oil and gas workers and so on, who spend a lot of time at sea and encounter turtles, and we can gather useful information from them. So we are going to use a number of different avenues for people to share information with us. One of these will be a free mobile app where you can submit photos of any turtles that you see. We also are going to have a Google form where divers can actually log their dives with us. So this would mean logging any dive, even if they didn't see any turtles. But from that, and then as well as reporting when they see a turtle, we get important frequency of encounters, which is important information, like what I did for my PhD. But, you know, me spending 2 years doing, or a year and a half doing 200 dives, we have, you know, several divers coming and diving frequently enough that we can amass a lot more information that way, if we can get them to participate, right? There may be other stakeholders who will not be inclined to participate by the TERT app, or may not have photos to contribute, but may have key information. So we're also going to be engaging directly with them. You know, this would include your fisher folk and your communities along the coast. So we hope to have a lot of meetings with them and so on. This is a look at the TERT app that we're using, just to see what it looks like. It was developed by this NGO called Protector Inc., which is based out of Honduras. And they've been using it successfully for a while. And what we've done is added the names of the beaches and dive sites around Trinidad and Tobago. And you can start logging, you know, your reports of photos here. Another great way we want to utilize as well actually is another app called iNaturalist that some of you may be familiar with. So if you share your turtle photos on iNaturalist, it gets added to our project that we've started there. And the value of getting the photos in is photos provide us insight into identification of different individuals. So it's a way that we can start counting the numbers of turtles encountered and looking at things like their pattern of movement. So say a photo was taken at Monas down the islands of an individual, and then we find that the same individual has been encountered at Gaspery or one of the other islands. It tells us a bit about how much these turtles are moving around. And the way it works, as I mentioned briefly before, is these patterns of scales on the side of the turtle's head are unique to each individual. So by taking good quality photos, particularly the side of the head, this we can compare one against the other and identify them. It's almost like a fingerprint, but you know, less complicated actually. So here's an example. I don't know if you can see it on the top of, yeah, you can see, you know, once you get a photo, what you do is you go back to your database and you compare it against different different photos you have and see if you get any match. So from here, you can see this turtle has quite a unique scale right at the top here, and we can detect that same scale in this photo. And then you can compare all the other patterns and you'll see it's all the same shape, right? So this can be done manually, or there's useful software that can do it faster for you. But the value of doing this, it will only work if we start to really gather a lot of photos, enough to start making matches. Right, satellite tracking is another useful tool that many of you might be familiar with. Primarily looks at your migration routes from one place to another. It can help us measure the habitat extent. So I'll show you an example of that coming up. We'll look at how long turtles stay in different habitats. You can include data loggers on this as well to get you things like the depth, temperature, and speed of movement. Because of the technology involved, satellite trackers started off quite large, and they were restricted to use on your adult mature turtles that would be taking, that would cope with this added weight and added drag on their shell. But of course, as technology is improving, the trackers are getting smaller and smaller, and now we're seeing use of them even in you know, turtles this size here on the left, very small post-hatchling turtles. So I have some tracks just to show you some results of some of the tracking that's been done around, mainly locally. So Turtle Village Trust would have tagged 9 hawksbill turtles, as far as I'm aware, last I checked. From these are nesting turtles from Trinidad, various places in Trinidad and Tobago. And you can see the tracks here. So you can see the majority of them are actually quite restricted around the Leeward Islands here. And so a lot of traffic in that area, but we do have others venturing further west, further south along the Guyanas here. And the thing with this sort of information is the more turtles you tag, the more you're able to start seeing if there are any patterns in the movements, which will then be important to protecting these species. We've had one of the species that we have in Trinidad and Tobago, but less common than the others, is the loggerhead. And back in 2017, we had a loggerhead stranding on East Coast beach here in Manzanilla in Trinidad. And after some rehabilitation, we were able to release it with a satellite tracker, thanks again to Turtle Village Trust. And, you know, it showed some really interesting patterns of movement. It hung around for a while on the East Coast. It then made its way over here into the Gulf of Paria, spent a little time around there in areas that are busy with industrial level ships, trawlers, and so on. Then made its way back along the North Coast to the East Coast again before setting off to we don't know where. So the tracker stopped tracking after a point. And as another limitation of these things is the battery life can be quite variable, and sometimes you only get like say this was about 4 months of data before it ended. And so this was very interesting because again, we don't see loggerheads very often. So this it's hard to say from one event if this is typical loggerhead behavior, but it suggests that, you know, maybe we have suitable habitat for loggerheads in these areas on the east and west coast that could be investigated further. Right, our leatherbacks actually spend most of their time foraging in very cold, temperate waters in the North Atlantic. And there's some tagging projects going on in Canada off Nova Scotia as well, where they track turtles. And this is a track of 2 different individuals coming back to Trinidad to nest. And you can see that they both took quite a similar path, probably making use of some of the surface currents to help them on their final approach, heading west onto our coast. And, you know, again, the more and more turtles you track, the more you can identify patterns like this in important habitat where we might need to investigate, you know, are there a lot of fishery interactions in this area, for example. Because leatherbacks, although they have been downgraded recently globally on the IUCN list from critically endangered down to vulnerable, our region, the Northwest Atlantic population has actually been downgraded again to, I believe it's critically endangered because we've seen some major declines in our leatherback nesting around the region, in particular Suriname and French Guiana. right? So we've had some local tracking done as well. Now, when our leatherbacks return to our beaches to breed, they nest multiple times. And in between those nests, which could be about every 10 days or so, in total, they may spend about 2 months here offshore the beach and nesting at, 5 or 6 times every time, 10 days. So Scott Eckert did some tracking from Grand River and Natura, which are 2 of our most important beaches, and found that the turtles tended to congregate and spend a lot of time in this northeastern region around Toco and Trinidad. So this was identified as what we call their internesting habitat, the extent of the habitat where they spend their nesting period, right? And that same study showed also where did they go when they leave, and when they complete nesting and leave. And again, we see them heading up to the North Atlantic. We see them heading to the west coast of Africa and even up close to Europe. Right. And on the other hand, here we have some of the first results of tracking of neonates, which would be your young, very young turtles. And this was 2014. This is the first study I'm aware of. So just the last 7 years, this is becoming a tool that we can now use to look at how these turtles distribute, and getting very interesting insights about where they go in relation to temperature, where they go in relation to the surface currents. And you can compare this with what you would predict if they're just following the normal drift with the currents. And it is interesting that they make use of the currents, but they are also actively swimming, and that active swimming can impact where they end up. So we're learning about how long they take to go on this path, and where they congregate and so on.
Hi, Michelle. I am so sorry, but I am going to have to cut you off. I feel so terrible, but we are 15 minutes to the hour, and we still have Dr. Kimberly Baldwin to present. And I would love to give her the chance to. So with that, we might finish around probably 3:15 or 3:30. And I know we're supposed to finish at 3 p.m. and I try my best to be as punctual as possible, but I hope that most of you all can stay on. And if not, the recording will be made available for you to watch. And I know some of you all are really enjoying it. But Michelle, what I can do is drop the slides in the chat for everybody to see and follow up from where you left off, which is passive acoustic tracking. And I know we were thoroughly enjoying it, but I really need to give Dr. Kimberly the time to present.
Of course,
and
no problem.
I'm so sorry. I'm so very sorry.
That's how it goes. No worries. I'm here for questions if needed, if people want to put in the chat as well.
Yes, there were some questions in the chat. So if you all have any questions based on what was presented thus far, please ask away. And I'm seeing Love the Turtle Talk. Thanks so much, Michelle. I absolutely love sea turtles. This information is great. So they were connecting with your information. So with that, like I said, I would drop the presentation slides in the chat for you all to have access to. And if you have any questions, ask away, or you could also connect with Species on social media, Instagram, Facebook, the whole lot. They are everywhere and stuff. So once again, Michelle, I am so very sorry. And Dr. Kimberly, the floor is now yours.
Great. I'm sharing my screen. Good morning, everyone. Can you hear me?
Yes. Yeah, all good.
All right. Slides. You can see my slide?
Yeah.
Okay, great. Good morning or good afternoon. I say good morning because I am presently in California at this moment in time. So I'm really excited to be here. And Khadija, thank you so much for bringing me on. I will try, for the sake of the group, go as fast as possible through my slides, and I can just let everyone know that I have plenty of other online resources. So if my talk is of interest to any young scientists, please just reach out to me, and you can follow me on socials. I'll provide that at the end. And I have a lot of webinars, YouTube channels, Instagram, everything that's got a ton of resources. So my name is Dr. Kim Baldwin. I am a research associate at the University of the West Indies in Barbados, CERMES, the Environmental Studies Department. I'm also the director of my own company, Marine Spatial Information Solutions. So just, I'm going to talk today about drone technology in particular, just because of the topic of our session today. But I also do a lot of work in GIS too, here in the Caribbean. So I'm based in Barbados, but I work all throughout the entire region. So just briefly, a little bit about who am I? I'm a marine ecologist, actually, by trade. I was born and raised here in San Diego, California, and I did my first degree at UCSB in California. I'm giving you guys a background because I know you're many young scientists that are on this webinar right now. And I think that the point of the story is I had no clue what I was doing when I started. And I had no idea when I started my marine biology journey, let's say 20 years ago, I won't age myself any more than that, where I'd be today, that I'd be using drones. So my background initially was pre-med, and I switched the last moment of my college degree to marine biology because I realized I just loved field research. I didn't know exactly what I wanted to do, but I just knew that I liked being outdoors in nature and doing ecology field research. So I decided I'd switch with zero experience or background in marine biology, but I had done a bunch of electives and jumped on that train. And one thing led to the next. I got my first job where I fell in love with the Caribbean in the Turks and Caicos Islands, working for the School for Field Studies, which is a study abroad program through Boston University. And that's really where I fell in love with the Caribbean, diving, and marine ecology in general, marine biology. I was doing teaching students in water how to do reef surveys. And from there and that, I was working for $4 a day. And I think young kids today forget that internships, even if it's not exactly what you want to do, you get a lot of experience. You might not get paid a lot, but it can help you. And I always encourage people to just do, when you're young scientists, try everything and see what gravitates, see what resonates, see what other opportunities. You're never too good for anything. Is the attitude I always have, and you should always be keen to learn new things. And so from that opportunity, I got an offer to come to the University of the West Indies in Barbados, that was 22 years ago, and do my master's at CERMES. And I ended up staying on and doing a PhD there. So my master's and PhD were in marine mapping. My emphasis at CERMES was fisheries and coastal ecology. I'm also a dive master. I've been teaching GIS and drones, but GIS for over 15 years at UWI. Many graduates all throughout the region I've taught. And I'm also now, since 2016, a commercial drone pilot. I have a license here in the United States, a Part 107 license, but I also have licenses in over 9 Caribbean countries. So I've been teaching and training people for since 2016, just in drones. But as I said, I have more than 20 years, and where my roots really are and where the drones came into the scene is that I had been doing environmental impact assessments. I've been doing marine mapping and monitoring, diving, doing field research, and GIS and marine spatial planning. And so when the drones came hot on the scene, all of a sudden I realized, whoa, I knew way back then this would be the next big thing. And I think just in the last year or two, everybody else in the Caribbean that works environmental management are realizing it really is. But the ability to buy an off-the-shelf drone and be able to collect images in real time about the marine environment and make more informed and accurate decisions was really when I just knew I had to get on that thing. So I'd like to start this off by really, in terms of marine spatial planning, marine ecology, and what the cornerstones of sustainable development, which are also the cornerstones of the principles that guide my work and my mission, is that we need to combine social, economic, and conservation priorities at the same time. And what I realized working throughout the region in GIS and creating all this data and doing marine monitoring is that really we needed to work more with people in order to strengthen our capacity across the region for environmental management. We needed to better, as scientists, be able to collaboratively collect and create more comprehensive information, not just conventional science, but social information, economic information, understand the dynamics of communities. How are people working together? And that was really this more wider participatory approach is what was needed to cultivate ecological health and social well-being on multiple levels. So at that point, I switched the mission of my work and my company to really look at tech more and use, how can we use tech and geoinformatic tools, off-the-shelf apps and drones and all these different types of technology and computer advances to strengthen the application of ecosystem-based management in the Caribbean. And I really shifted my work from that point, from planning and creating data to training and capacity building. And back when this started, maybe in 2010, 2008, I was focused more on GIS, using Google Earth and other tools to create holistic information and work with communities to map local knowledge of problems and issues and solutions. And then obviously I got into the drone. How did I get into the drones initially? Well, initially I'm self-taught. You can see up in the top right corner, I have two brothers. And in 2015, we all got our first drones. Both of them are photographers. One's a big famous YouTuber, and the other one is a surf photographer, and I was a marine biologist. So we all got our drones. They were gamers. They were amazing. And day two, I shut off my engines in the air and my drone dropped out of the air. So I learned pretty quick the ins and outs. And I got my first job, actually. I knew I had my first job with drones before I even bought a drone, because I'd been doing the GIS mapping. So I was already out on a mission or had a job to actually train people and develop a drone procedural operations manual for the government of Antigua. So I developed my first training curriculum for drone mapping in 2016, actually, the same year that I became a commercial pilot. But the way I was trained, because I was trained by some experts from the US in a very short period, and then I had to develop a curriculum to train across the Caribbean, that the technology wasn't really appropriate for our needs in the Caribbean. So I did a lot of work. I could say I probably did a whole nother PhD since 2015, researching all the various drones, hardware, equipment, software, as well as the different ways we could use drones for environmental management. And so over the last few years, I've really developed and identified tools that are easy to use, but relevant to the Caribbean context, to our skills, our capacity in terms of internet access and data, as well as money, right? A lot of times we see these really cool solutions, but you think living and working in the Caribbean, we can't afford that. So that's where my research and my focus has been in terms of the drone, integrating drones. So why are drones being used for environmental monitoring and management? Well, there's just the main reasons why, and it's more the monitoring and management. People are using drones for working purposes besides photography are A, ease of use, usually also cost. If you're using an off-the-shelf drone, you can buy a mapping drone now for about $1,000 US. And a lot of times for science, it's really useful because it allows us in a very minimally invasive ways to access places and collect information in ways that were virtually impossible. There's a whole different variety of ways that I've worked with teams and agencies. Like I said, I've probably worked in over 10 Caribbean countries in the last few years on a variety. These are just some of the ways that I've used drones for the environment. The biggest is mapping and monitoring environmental changes, understanding changes over time, understanding effectiveness of marine protected areas or different management measures, being able to capture and create digital twins, let's say, of historical sites, or use drones. More recently, since COVID, I've done a lot of work with FAO and drones for national food security. planning and using drones, machine learning, and AI tools to identify the health of crops, but also when to harvest them. Using drones a lot now, more recently for climate change, understanding impacts before and after disasters, and how to get in and manage and deal with it. What's the most effective way if all the roads are blocks for people to get in? Also using drones to, my favorite is participatory mapping and understanding the socioeconomic drivers. And, when there is a disaster, or sargassum, who's being impacted, whose livelihoods, how many users are there? And by having an aerial picture even, let alone a drone map, you are able to glean a lot of very useful information. But because this is a Caribbean talk, I would like to talk about, it is a bit more challenging working in the Caribbean, perhaps, than maybe other places in the world, which I find exciting. I always tell my students at UE, you know what, you don't see it going to UE. Some people say, oh, well, and I went to UE, I did my master's and PhD at UE. And so you think, oh, we're behind the rest of the world, or, oh, if we only had funding the way they do in America or in the UK. No, that can be a huge benefit. It teaches you how to, I like to say MacGyver, it was an old school show back when I was a kid, but how to rig things. You have to use your head in the Caribbean, right? Because we don't have all the big money everybody does. So sometimes you need to be thinking more in the entrepreneurial spirit, which is why I love working with young people, because there is so many new technologies and ways of doing things that maybe older generations aren't even thinking about. So as I mentioned, there's a challenge in terms of we a lot of times have inadequate resources. Working in the Caribbean, we have extremely challenging environments. We've got wind, we've got heat, we've got humidity. The terrain, a lot of times, hard to access, to get into. We don't have data and cell signal, or, either you can't afford it, or maybe you don't have it in the areas that you're working in the mountains or in the remote areas. Many times in terms of capacity, we have very limited amount of computers and a software available. Then a lot of times, in our last presentation, we were talking about sea turtles. We're working across the whole region. Animals and marine life, and even our atmosphere, sargassum, it's going across the region. You can't just manage in your country climate change, right? We need to take a wider approach, and not just a geographical extent, but also the various levels of people that you need to engage or understand environmental management. It ranges from the community level to maybe the national level. We've got government decision makers, and we've got researchers, and then we also have the whole world, right? And the public that we need to engage. So this is where I find drones very, very useful. So when you're looking to apply drones for environmental management, I can't really get into details because I'm trying to make up here a bit of time. You need to clearly identify and understand, what do you want to use drones for? People get really excited and they're like, yeah, drones. No, I always tell people, reel it back. What are you trying to do with the drones? What data do you need to collect? What scale, what resolution? Because the more detailed data you need, the exponentially more it costs, right? So you need to find, you always in science need to find that sweet balance. What is the application? Is it for management? Is it for science? Is it for outreach and education? Because there's different types of data and information you need for different accuracy of data, but also for different audiences, right? I'm not going to be showing a group of fishermen hardcore GIS data. If I show them a really great 360 pano or a great video, that might be more engaging to have conversations with. So you need to understand all of that to identify which drones, which software, what type of training, and what kind of monitoring plan you're going to set up. So today I'm going to use a case study. I'm going to talk about sargassum management because that is something that is pretty much impacting every country in the Caribbean at this point in time. And so I was approached with the same question. So I'm going to walk you through my typical thought process when I determine how I'm going to use drones for environmental management. So back in 2018, Professor Oxenford at Cerames approached me, and she wanted to understand, well, she was just doing it in an old school science way, how much sargassum's washing up on the beach. So they were scooping up buckets and measuring it and then running quadrats and transects and then trying to interpolate this mathematical formula to estimate how much is washing up on the beach. And I saw what they were doing and I was like, this is ridiculous. We could be flying a drone, we could be using AI, machine learning, and I could probably tell you in a matter of minutes how much sargassome's on that beach without having to lift heavy buckets and do all this work. So that's where my journey began. So as I mentioned, the first thing I said to her is, what are the applications or purpose that we want to use drones for? And she said, well, first, and this is typical of most drone applications, you have multiple applications that the information could be used for. So you really want to make a good game plan before you go out there and start collecting data. All science. This is, again, I'm talking about drones today, but this is what I teach in general when I'm teaching people about environmental mapping and monitoring is identify your need, your application first. So she said they wanted to understand how much sargassum is washing up on the beaches for management, for cleanup purposes, for the entrepreneurs that wanted to use it. We didn't need to know exactly to the centimeter how much was there, but just how many truckloads, how many boatloads, what was the general quantities washing up across the Caribbean? Because if we're going to try to get markets to invest in sargassum, let's say for biofuel or fertilizer, we needed to know how much across the year, what was the seasonality and how much and where was this stuff washing up on beaches. Next there's another group of scientists at the university I'm working with that wanted to use the information for local knowledge mapping, for development of national sargassum management plans, and to understand the impacts on communities. So we needed that type of information. And then there was also another component of our project that was really looking at collaboration with different groups, with public participation, education, and outreach. So I had multiple applications when I started to develop this monitoring protocol that I wanted to encompass in the data collection. As I mentioned, I started this research in 2019, and it took me about 3 years to develop the workflow that I have developed today that we are now scaling across the Caribbean. But I did a lot of research in different types of drone flight plans, mapping surveys, what pictures, what videos would be useful at what flying heights, at what angles, etc. I also got a grant from WCS, the World Conservation Society, and National Geographic to get underwater drones to see, we wanted to look at the biodiversity of the animals under the water as well. So this is really exciting. We're using drones aerially and underwater to understand sargassum management. And then, because I am a scientist, there's a lot of automated web dashboard tools, machine learning, automated tools that were out there, and I didn't really trust them. So I did a lot of research in the field, measuring things, let's say, the volume of sargassum or the height of sargassum, and then running it through the GIS and the automated tools and seeing how accurate was it, right? Because I didn't want to put my name on this and go out there and train people unless I knew it was indeed true and correct. So I did a lot of work on that, the GIS, like I said, these automated, because again, I wanted to scale this across the Caribbean. And as a GIS lecturer of over 15 years, I know, and I'm teaching master's students, GIS is not an easy thing to learn. It kind of stresses people out, especially at the beginning. The learning curve's high. So I figured out how to do the workflow in GIS, but it was very difficult. And so I said, okay, are there other tools out there that are easier to use that we could maybe use, and then it would spit the results out into GIS? And then again, we didn't have big, strong computers. I did because I'm a nerd and I'm a GIS person, but you know, on average, most of my stakeholders had just a regular laptop. They didn't have supercomputers. They didn't have storage space, drone data. When you go out and fly, some days I'm collecting up to 10 gigabytes of data a day. So how are we going to host and share and access all this data across the Caribbean? So these are some of the challenges I had to think through and work through over that 3-year period. So I ended up for this application choosing a drone mapping software called Drone Deploy. As I mentioned, there's many different software packages out there, and there's different, and so someone says, what's the best drone? What's the best software? It depends on your application, okay? There is no one size fits all solution. So for this application, I chose off-the-shelf DJI drones. We were using Phantom 4s at the time and Mavic 2 Pros. There's different drones now, okay, because the drone world's progressed. So I can't get into all the models that we're using today, but a mapping grade drone, just an off-the-shelf with a regular camera. And then Drone Deploy is a software that allows you to fly and create drone maps, but it also allows you to upload into the cloud, and it's processed virtually, so you don't need a big computer. And then it spits you back your information in a web dashboard that allows you to analyze and explore some of the trends and also create a summary report in a PDF. So this really was a game changer for me. It helped me get over that regional GIS capacity bottleneck that I've had for 15 years. I've been struggling with this in many projects I work on, collecting GIS data around the region. So this was a really exciting project and development for me. And then we got support from Drone Deploy, who is now giving free drone software to all my teams around the Caribbean collecting sargassum data. So this has been exciting. I also, as part of this research, have developed a sargassum monitoring protocol. We have a good practice users guide, which I'll share at the end, but also a drone training course. So the caveat is that all of these people that I had trained this summer, I trained people virtually, but they had already received a 1-week boot camp. So they had already learned how to fly drones and how to use mapping software previous to this very niche specialized drone for sargassum monitoring protocol. So I teach in person, but I also have a virtual training academy online that I built since COVID. And so I launched that class virtually through my training academy with live Q&A and webinars every week with my teams, but it guided them through self-paced lessons and videos, and then they would go out. And so over a month period, we identified and set up monitoring sites. So I guided my students, A, into planning the mission and selecting their monitoring beaches, B, to setting up and conducting drone surveys. So not just how to go out there and do the surveys, but also safety assessments, feasibility assessments. And then, like most drone data, it doesn't just spit out. Drones don't replace people. They don't replace scientists. They just make our jobs easier. So for most drone applications, you still need to do some ground truthing data. You still need to give it some field data to make the information the most usable. So for the sargassum monitoring protocol, you still need to do very quick, rapid field surveys looking at the depth with a little stick on your beach of the sargassum. But the rest of it is all done with the drone and some Excel analysis that I'll talk about in a minute. And then we trained our teams how to deal with the data, how to manage it, how to assess the quality, but also how to use these web analytical tools and create summary reports on their monitoring beach so that they could share, whether it's through the report or web maps or 360 panoramas or videos, with their stakeholders, the information they had been collecting. So I can't get into this well just due to time, but the drone monitoring protocol is not just you go up and you fly one thing. We actually are doing 5 different drone surveys at the beach, and each one of these surveys has a different end user and purpose and application. Some are for the communities, some data is for the abundance of sargassum, some of it's just using for the participatory mapping aspects. And then some's like other scientists are using for the forecasting models. They want to see, are their models true and correct? So this is publicly accessible data. It's free access through Drone Deploy, and that I can talk about later. So here's some of the results I just want to say. So step 1, we went out, here's an example for my team. So I trained teams in 5 countries under the SargAdapt project, which was the grant that funded this. So here's some results from St. Lucia. Step 1, you conduct your survey. Step 2, you need to do a very rapid beach survey. Now, this entire process can happen in under an hour from flying the drones and the beach survey on any beach, no matter how much sargassum you have. So we've developed this to be very easy to use, rapid. So you do need to do, as I mentioned, some very basic ground measurements, which our user's guide and my training course has videos and explains exactly how to do this. I think, let's see if I can show you very quickly. Yeah, this is it. quick time-lapse video. This shows Michaela and I. So we did our drone map, and then we do this very quick survey. We run 5 transects that you can get done in a matter of a few minutes to get our data. So then you go back and you have to deal with your data. So you have to upload your drone data into the Drone Deploy dashboard. And there's some different analysis that we train students how to do in Drone Deploy, but also there's some Excel work too that gets done because you have to enter your field work, but we provide an Excel table that has like the macros built in. So you basically enter the data and it spits out the results. So wrapping up here, the flight survey. So what was the steps? 1, we conducted flight surveys. 2, we train people, or we've working with people to use automated, not GIS, using web mapping tools that actually will help classify and understand the volume and, you know, the beach profiles and the different information you need. Beauty is, here's just some more examples of, you can measure things in 3D. You can get volume of sargassum within this. And like I said, we did a lot of tests back and forth. But what I love is that this can be perfectly, or it can be exported, all the data into GIS. So you can create GIS data and share it with your GIS analysts without even having to know much or anything about GIS. So then we train people how to create these reports, how to understand accuracy, or if there was any problems with their drones, their drone surveys. Like I mentioned, we're also collecting 360 panos that could be shared on WhatsApp, that can be shared as URL links, because there's different stakeholders that don't really care about seeing the map, right? They just want to see pictures. That's what gets them engaged. So you need to understand your audience. And I think another great point here for the young scientists in the crowd is, my skills is not so much my brain. My skills are social, being able to work and communicate with people. And I think as a scientist, especially when I started, I never really took that skill. I just thought it was kind of second nature. And the more and the older I get, I realize that that's a very important skill. So if you're a young scientist that's just maybe a little more into people and you can communicate and work with people well, you know, there is a great, bright world ahead of you in terms of science, and you are very needed. There are many scientists that cannot communicate with people. And that is something that I really want to encourage people today, that, you know, all scientists, they're not wearing lab coats and these nerds in the lab doing genetics and other things. You know, there's a lot of people like me that are out there just working with people. People are the ones we need to manage more than the animals a lot of points in time. So in conclusion, just this first cohort of training this summer, like I mentioned, we trained over 51 people from 21 organizations. This is just a really pretty infographic of sort of the breakdown of who was trained. Now I'm moving on with this research. I've trained now in September the next cohort of students, which emanate from the countries of Anguilla, Montserrat, and the British Virgin Islands. And I'm building on under the next grant funded by Darwin Plus and implemented by Canary and Trinidad, how to use the drone mapping information for a different application, which is that participatory mapping of the social and economic information, as well as the local knowledge, the community's impacts, the community's mitigation measures and solutions as well. So I'm really excited about this next phase. Also, if you're interested, I'm going to share, I can share with you a paper that I published. It's available also on the CERME's website, but it is an overview of how drone technology can be used for participatory mapping of Caribbean coastal communities, fisheries, climate change issues, etc. And with that, I'd like to conclude and just say thanks. I've added a QR code that you guys can scan that gives you a lot more links to my socials, but also to other podcasts, videos. I think a podcast that I did with Kadiha, the EcoVybz podcast, and I've got several other YouTube videos. I try to get out on different types of networks. So if you're interested in learning more, I also have you could email me, you could check my training academy, drkimbaldwin.com. And I'd like to thank particularly CERME's, the University of the West Indies, and the Caribbean Biodiversity Fund, who funded a lot of that sargassum research. All right, so Thanks. Do we have time for
Thank-
questions, or are we done, Kadia?
Thank you so much, Kimberly. I'm seeing, whoa, this was extremely interesting. Love it. Thank you all so much for staying on. I feel like we could get maybe 2 questions in. So the first 2 people to ask questions, if you have any, now is the time, go for it, or else you would have to reach out separately on social media and stuff. I am not seeing any coming up in the chat, but
Great.
I just need to let you know that when SOA is organizing its next set of funding, I am going to put in there for you to come to Trinidad, as well as train some of the other youths in Barbados and some of the other islands on using drones for marine conservation, because I think it's extremely cool what the work that you have going on. And I'm seeing a lot of great presentation, love the work you're doing, and very interesting. So yeah.
Yeah. Do you know, I just love, especially training. I mean, when I was in this last overseas territories, I mean, I trained several people that were 18, 19 years old, 20 years old. And I just love training young people, because you guys grew up with this stuff. You grew up with the tech. You know, it's not that the old people can't do it. They can, but the young people, the rate and the skills. I mean, even when I talk to ministers in the Caribbean, it's a very small investment. And using drone mapping is something that it can be scaled very quickly across the Caribbean and train people very quickly with just a little investment.
Yeah, I'm seeing someone is saying I use drones for my final year project and I would love to connect. So Kimberly, if possible, maybe you could drop your details in the chat while I'm giving my wrap-up speech.
Yeah.
But
And I think I put the thing up there, but I put the link tree up there, but I'll put the link tree in the chat right now. Thanks, Kadia.
no problem. I see Carla is asking if there's something like this going on in Puerto Rico, like if you're doing training in Puerto Rico right now.
I have not had any requests in Puerto Rico, because that's the US, not because it's US. I train up here in the US, but no, most of the funding, because I usually put on a lot of trainings under grants for organizations. So it just depends where the funding, but I've got like 15 coming up next year, but Puerto Rico is not one of them.
Oh, well, we'll see if we can add to that
Maybe.
number.
I'm open to it.
Yeah, and I'm also seeing our last speaker, Michelle, is saying excellent presentation, Kim. So many possible applications and very important points about study design and adapting to limitations. And quite interesting, the next slide on Michelle's presentation actually talked about using drones in sea turtle conservation. So you came in at a very good time, talking about drone technology and stuff. So
yeah, I trained the sea turtle project in Barbados. One of the slides that I had with the red circle, that was actually a leatherback nest, because now they're able to fly 9 kilometers of beach, you know, and they can zoom in and see and mark turtles without even, you know, and their accessibility, the remote area of the East Coast was what their hold back was. So great. Thanks, everyone.
Yeah, so maybe there could be some connection there for sure. Once again, guys, so sorry that we had to go over time. It's like now 3:22, but I'm very happy to see that most of you all stayed on. And Michelle, once again, very sorry that I had to cut you, but like I said, all the slides, presentations, everything will be available on the drive, and we would send you all that information so you'll be able to get it and go over it at your own time and own pace, as well as the contact details for all our speakers. So I once again would just like to give a very big thank you to you, Kimberly, to Michelle, to Brandon, and to Jeffrey, our amazing presenters today. I feel like we got a lot of information, and one of the feedback I keep getting from the session so far is that people are now seeing new avenues they could go into the marine science space. So that is one of the goals. So I'm very glad that, you know, with your presentations, we are opening the minds, and I love that. And tomorrow's session is a different time. Let me get that up real quick before I give you all the wrong time. So tomorrow we start at 10 a.m. and tomorrow's session is Ocean Science in Action, where we'll be looking at AI technology and whale monitoring and like marine robotics and stuff like that. And it would not be as let's say we won't have as much equations tomorrow as we had today, but still very much interesting and engaging. And once again, so happy that all of you all joined and stayed on. And I look forward to seeing you all tomorrow. And don't forget to fill out the attendance. And if you missed previous, well, it was only yesterday. So if you missed yesterday's session, the recording will be sent to you as well with questions. So I'm seeing a lot of thank you, Dr. Baldwin, and thank you, everyone. So with that, enjoy the rest of your Wednesday. Kimberly, you have the whole day ahead of you. We are already late into the afternoon. So everyone, enjoy the rest of your day, and we will be back tomorrow. And remember, if you are interested, definitely reach out. All of our presenters thus far are very open to connecting with you. And trust me, they've connected with me because I sent a random message on social media and they responded. So do reach out and do connect, and I'll see you all tomorrow. Bye, everyone.
Bye.